Hi, everyone. Welcome to Konveyor Meetup. Today we have a community team, the Move2Kube team, who will be going over the newest capabilities with their open source tool, Move2Kube. Before I hand it over to them, just want to go over a couple announcements. So the community is having a Hackfest next week. It will be from 9 a.m. to 4 p.m. Eastern. This is the way for you to learn the tools in the open source tools in our community and find ways, cost-efficient, time-efficient ways to move different types of workloads to Kubernetes, and also get support from the community while you're doing it. So remember this, if this is also your chance to give us feedback and just give you better tools that you can use after this event is over. I'll put a link to a blog just giving the details on it of it. And if you're interested in joining, just fill out the form that we're linked to in that blog. And that way we know to send you a calendar invite. Outside of that, the Konveyor community is going to release a state of application modernization report probably in about 2 months. We don't have it ready yet, but if you do want to get it once it comes out, make sure you subscribe to konveyor.io. That's where we'll send out the first updates on the report, or we'll send it out once it's ready. And other than that, that's all I have. So with that, Ashok, it's all yours.
Thanks, Jonathan. Hi everyone. So today we from the IBM research team and the RARE team are happy to present about the Konveyor Move2Kube work. We recently had the Move2Kube 3.0.3 release of our open source tool, and we would like to talk about the new features. We are very excited about the new features there, which we believe will help you automate all your modernization journeys. With that, let me quickly share my slides. Okay, so yeah, so as you all know about the Konveyor community, we are here to help in the journey to Kubernetes, and one of the tools in the journey is Move2Kube. And Move2Kube is about helping you refactor your applications to run on Kubernetes, and it might be an application which is running in Cloud Foundry, Docker Compose, or just a language app which is running in your VM, right? We want to translate it. We had multiple previous releases where we had opinionated ways where we would use and transform your artifacts to run on Kubernetes. And when we worked with multiple enterprises, we realized the need for customization of your artifacts. So with this new v0.3 release, we allow for extensive customization capabilities, which allow for creating the exact set of artifacts that is required for your organization. So what we will be going through today. So we'll go through the intro of what Move2Kube is for people who are new to Move2Kube, and then we will talk about some of the capabilities of Move2Kube, and then we will delve deep into the customizations, which is new in the v3 version. Do feel free to put your questions in the chat, and we will be answering that at the end of the sessions. Okay, so few of you might already know about Move2Kube, but for those who are new to Move2Kube, Move2Kube has the capability to understand all your source artifacts, the runtime information, and all information that is available in your Git repositories and runtime metadata, and take all of them and help you create all the artifacts that you require to run your application in Kubernetes. For example, you might have an application running in Cloud Foundry or Docker Swarm, or it might be Java's Spring Boot apps or .NET apps which are running in Windows or Python applications, right? Or you might have a custom application in any language. Move2Kube can take that application, find the right way to containerize the application, and extract all the properties from the application that are required for deploying it into Kubernetes. For any missing information, it can interact with you so that it can fill the gaps, and then create all the destination artifacts out of the box. Right? The destination artifacts it creates out of the box include like all the Kubernetes Yamls that you are interested in, the Helm charts, customized Yamls templates that you want to deploy to your cluster, the Dockerfile you need to containerize your application, and even the CI/CD pipelines and Knative artifacts for serverless or automating the build pipelines. Or if you're interested in a custom artifact to be created. Let's say you want to create Jenkins pipeline or Terraform artifacts. Move2Kube has an extensive templating engine capability too, which you can use that. All of this we will be seeing very shortly. Okay, so now let's take a step back and look at how a tool like Move2Kube can be used in enterprises. Right? Enterprises have thousands of apps, and there will be multiple categories of apps, Node.js apps. You will have Java apps, you will have Python apps, and there are a lot of them. But they generally follow some patterns. So when we work with our clients, what we generally do is we pick 3 or 4 apps that are representative of the entire catalog, and then give it to Move2Kube. And Move2Kube will automatically analyze them and create all the destination artifacts. And once it generates all the destination artifacts, the users can look at them and see, okay, this is fine, I'm able to deploy. But you might realize that for your organization, you might want to use a different base image, or you might want to have a slightly different Dockerfile. You might want annotations in that, or you might want a different folder structure. You might look at them and understand your needs. And once you understand your needs, what you can do is you can go back and encode all of this in the form of customizations to Move2Kube. And once you encode it, Move2Kube then can automate the migration for all the rest of your apps. So let's say you have chosen 4 or 5 representative apps, and you have translated them, and you have done this customizations. And for the rest of your 1,000 apps, you can Move2Kube will create the exact artifacts that you need for those 1,000 apps to be deployed. There are extensive tutorials about this in the Move2Kube.conveyor.io website. So if you head over to Move2Kube.conveyor.io here, in the tutorial section, you see different scenarios where how to use the Move2Kube CLI, the Move2Kube UI, running in non-interactively, or moving from Cloud Foundry to Kubernetes, Docker Compose to Kubernetes, and a lot more use cases. Right? And even for industrial scale translation, what you can do is there. So do feel free to head over there and try it out. Or you can also join us in the Hackfest, as Jonathan was mentioning, in early Feb to get a hands-on experience on this. Now, let's have a quick look at how to use Move2Kube. Move2Kube can be consumed in multiple ways. You can either use a command line tool. It's just a Go-based command line tool. You can just use the curl command or brew install to get it in your system, and you're up and ready to go. Or we have a very powerful UI, which has all the capabilities that a command line provides, and even more, which you can also use to do the translation. We will have a demo in each one of them in a few minutes. Okay, so let's consider you have an app which has multiple language apps. Let's see how to translate it, right? How easy it is to translate it. So, for example, let's consider this folder there. It has multiple folders within it, which has apps in different languages, all hello world kind of small apps just for the triad. Right? So let's see how Move2Kube can understand all of this and translate it for us. So all I'm going to do is to head to a terminal. I have Move2Kube in my terminal, and I'm going to give Move2Kube, and then I'm going to do Move2Kube transform and -s, and all I'm going to do is to give the language platforms. So I don't want to interact with it. I just want it to create the right artifacts for me. So I'm just keeping that given. So once I do that, let's see what it does for us. So it's going through each and every folder, tries to understand what is there, can it translate it, and then it's trying to see whether how to parameterize it, how do I create the Kubernetes Yamls. It tries to do all of that, and will come up with the final artifacts for us. So Move2Kube has now done its job, and it has put the output in the My Project folder. So let's see what's there in the My Project folder. So here is the output in the My Project folder. So if I look at the source, in the original source, it did not have any Docker files or the containerization artifacts. Now Move2Kube has added the Docker files for all the projects. In addition to that, it has created some scripts for running them and some deployment artifacts. Akash will be showing more details about it in a few minutes, but that's how easy it is to use Move2Kube on your project. All you do is take your source code, point Move2Kube at it, and it will create all the artifacts for you. Now, there is more involved usage where you have multiple step processes where you have a plan phase to plan your migrations, transform, collect information from runtime, and so on. We'll look at that also in a few minutes. Okay, let's go a step further and look at how Move2Kube really operates. The understanding of that will help us understand how to customize Move2Kube. So Move2Kube, you might have noticed that it's able to understand various languages, create multiple artifacts and stuff. Now, when you create such a powerful engine, if you tightly integrate all of them, the challenge that we run into is it becomes less customizable. So what we have done is internally within Move2Kube, we have something called transformers. Those are small nuggets, each responsible for a particular job. For example, then there are some Java transformers, there are some Node.js transformers. These can understand this folder has a Java project or this folder has a Node.js project. And then it will create some Docker files for it. And then there is another transformer called Dockerfile parser, which, I now have a Dockerfile. How can I create a Kubernetes Yaml for the Dockerfile? So then it hands over to a Kubernetes transformer, which creates Kubernetes artifacts. Now, there will be another transformer, which is a Helm chart generator, which sees, there is a Kubernetes artifact. I know how to create a Helm chart out of it. And then it creates that and puts it into it. All this while, if there is any of these transformers are missing any information, it will interact with you and ask the questions for you. This is how Move2Kube works at a high level. We talked about transformers. Let's look a bit more deeper into it. So there are two phases in Move2Kube internally. What it does is, in the first phase, the transformers can go through folders and understand whether the folder has a project that it can understand. For example, a Java transformer will look at the project and say, is there a pom.xml? Is there a Gradle file? And try to understand this is a project with some properties. It will also go into it, find what ports it's running in, what are the properties, the environment variable it has, and any information, additional information. And then it creates something called what we call as artifacts. And these artifacts is what is, you can consider it like a message, right? Each transformer creates an artifact. And then whenever another transformer sees the artifact, it understands, right? So there will be another transformer which notices that this artifact is something I can understand, so I can process it. And then that transformer can create either another artifact, or it can also create another entity called path mapping. What the path mapping is nothing but it says, okay, create this folder with these contexts. That's what a path mapping is. The aggregation of this path mappings of the different transformers ends up with your final result, which is your destination folder. We need not get into too much detail of this. You will understand all of this from the website if you want to customize. If you don't want to customize the output of Move2Kube, you can just run the one command and you are done. Even to do minor customizations for changing the folders and stuff, as you might hear from the team in a few minutes, it's much more easier, and you will not, in most cases, you will not be getting into the depths of all this transformers. Okay, with that, let's go on to see how to customize these transformers. So we talked about inbuilt transformers. There are three ways you can customize the transformers. One is that we talked about multiple inbuilt transformers which are performing different jobs. You can take any of these transformers and give a configuration to it so that you can change its behavior. For example, let's say the Kubernetes transformer is putting the output into a particular folder, and you now want to change it to put it in a different folder. You can use the configurations provided by the transformer to change. Or we also have a scripting capability in Starla. You can create a completely powerful transformer in Python-like language called Starla, where you can say, oh, this is exactly how I want to process the code. And this is the exact output I want. This is how I read the input. You can write all of it. For people who even need more power, right? You want to write it in your own language. You want to write it in Java. You want to write it in some other language. We can write the transformers even as containers. So every other transformer will reside as it is. Your container-based transformer will be part of the entire flow and will still perform the job. This gives you the entire power of a full programming language to do any kind of transformation that you want, and still leverage all the inbuilt transformers and multiple different transformers based on your requirement. Okay. So there are many tutorials as I showed in the website. So you can head over there and try them out. Here is a link to the website Move2Kube.conveyor.io/tutorials. We also have a very powerful UI, as we mentioned, which also supports authorization and multi-tenancy. So if you're an enterprise user who wants to deploy it for your entire enterprise, you can very well use the Move2Kube UI out of the box. Okay, let's talk a bit about whether we have used it in multiple use cases. Yes, we have used it with multiple enterprises, and here is one simple case study where we have used it in a client who wanted to move from Docker Swarm to Kubernetes, and we saw about a 9x improvement in the performance in creation of artifacts time. Because a user who is first trying to create the artifacts needs to understand the source platform, understand the destination platform, understand the mappings, and convert it. Since all this knowledge is already encoded into Move2Kube, it automates this entire pipeline for you, so that if you have 1,000 applications, you can have a much smaller team with which you can do the migration. We are also looking for more contributions, so do head over to the websites if you are interested in. With that, let me hand it over to Akash to give you a demo of the various capabilities of Move2Kube with the Move2Kube UI. Akash, over to you.
Sure, thanks, Ashok. I'll share my screen. Is my screen visible? Can you see my screen?
Yeah, we can see it, Akash.
Okay, sure. So here, like in this demo, we'll see how we can use Move2Kube to migrate a Cloud Foundry based enterprise scale application. So here we have an application. It has mainly three components. One is the front end, other is gateway and orders. So front end is Node.js based application, and gateway and orders are Spring Boot applications. And they are already deployed on Cloud Foundry. So you can see that they are up and running on Cloud Foundry. Now, one of the features that Move2Kube provides is that Move2Kube can collect the runtime information of the Cloud Foundry running instances. So first we'll see how Move2Kube does that. For that, we just need to run a simple command, Move2Kube collect. And it can also collect the information about the Kubernetes cluster if you are logged into any. But for this demo, I'll use the annotation flag -acf, so that it just collects the information about the running instances in Cloud Foundry. So here Move2Kube is, I'm already logged into my Cloud Foundry account, so using CF login. So after that, we can run this command to collect the information of the applications which are running in Cloud Foundry. So the output is there in M2K collect. Let's see what's there inside M2K collect. So Move2Kube has collected the runtime information. It has collected like the name of the application is orders, and it has also collected like which kind of build pack it's using, and if there are any VCAP environment variables, then Move2Kube also captures that. So it has captured the information about all the three services. And now let's go over to Move2Kube UI, and we will see how we can create the target artifacts to deploy this application to Kubernetes. So for this, what I have done is I have already zipped the source folder into a source src.zip and M2K collect into runtime.zip. So this is the Move2Kube UI. First, I'll create a new workspace. a demo, and then I'll create a new project, Cloud Foundry to OCP cluster. And here now move to cube. In move to cube, we can upload the source artifacts. So first I'm gonna upload the src.zip. The file got uploaded. Next, again, next I'm uploading the runtime information that move to cube has collected for us using move to cube collect. That also have input for that also I have selected input type as source folder, and we also have a config file which has some information about the applications. So for that I have selected the type as config file, and it has also got uploaded. Now the next step is to run move to cube plan, and for that I have clicked on start planning. So internally move to cube is going through each and every files and folders and trying to identify what are the services that move to cube has detected. So it has detected the front end service, it has also detected the gateway service, and the transformer name is Cloud Foundry, and it is also incorporating the runtime information which move to cube has collected for us, and there is also this order service. So next we run the transform phase by clicking on start transformation. So here move2kube will basically ask some of questions to you, uh, like choose the cluster type. So any cluster type can be chosen here: OpenShift, IBM OpenShift, Google Cloud. Here for this demo I'm selecting Kubernetes. So, and it asks to provide the ingress host. So I'll be deploying it on Minikube. So here I'm specifying it as localhost. So the key thing is that for the Cloud Foundry for using Move to Cube for any Cloud Foundry application, we need to have the source code or the source binaries with us. The runtime information is an optional step, but we need to have the source code of the Cloud Foundry application with us. So Move Cube has generated the target artifacts, and now I'm downloading it. Let's see what's inside the generated target artifact. So it's generated inside the output folder. Let's see what's there inside the output folder. So essentially the folder structure looks very much similar to what we had provided to move to cube. But what move to cube has done is that move to cube has instrumented or added this Docker file, which will be useful in containerizing these applications. So let's see, like the Docker file for the orders app. So move to cube has created the Docker file for the orders application, and similarly it has created Docker files for gateway and front end as well. Now, additional to that, Move2Kube has also generated the scripts that can be used for building the images and pushing it to your registry, whatever registry you have specified. Here I have specified the registry as que.io and given my namespace. This information we had provided in the config.yaml file, which I uploaded on Move2Kube UI. So Move2Kube has generated both the scripts for building the images and for pushing the images. And Move2Kube has generated the deployment related YAMLs for us. So here you can see it has created all the YAMLs for all the services that we had. It has created the deployment YAML for front end. It has created the service YAML for front end. Also, the information that it incorporated from the Move2Kube collect output. So if your application had any vcap environment variables, then it would be captured here in the secret. Similarly, it has created the deployment service artifacts for other services, and it has also created the ingress file for us. Also, Move2Kube has created Helm chart related artifacts, and there is also if you want to test it locally, then Move2Kube has created a Docker Compose YAML file so that you can test it locally before deploying it to a Kubernetes cluster. And also Move2Kube has generated a Tecton related CI/CD pipelines which you can integrate to have a CI/CD pipeline running. So Move2Kube has generated all these artifacts as well. And now let's quickly see how we can use these generated artifacts to deploy to a Kubernetes cluster. So I'm already running a Minikube cluster, and so this is the output. And Move2Kube has, as I've told, that Move2Kube has generated the YAMLs inside the deploy folder. So I'll simply run kubectl apply and provide the path to the deployment YAMLs, which is deploy/YAMLs. So it will deploy all the services, the deployment services and ingress. And now we can check the status of the pods. So the pods are running. I had already deployed some pods, so they are terminating and recreating the pods. Also, we can check the ingress. So the ingress is also running. So we can check quickly some of the applications, whether they are up and running or not. So this is for our gateway application. Oops. And this is for the orders. I think it's due to Minikube tunneling. So this is for the orders. Also, like there can be particular things to your organization. Maybe you want to bring in best practices or some policies which need to be incorporated with the target artifacts. And for this, Move2Kube allows adding customization modules based on Starlark scripts or custom transformers. So I would like to invite Nabha to show like how we can use Move2Kube to customize the output. Over to you, Anabha.
Thank you, Akash.
Okay.
So let me share my screen. Is my screen visible?
Yeah, you're good now, Nava.
Okay, thank you. So Ashok had mentioned in the beginning of the talk that Move2Kube has follows a particular framework called the transformer framework, which allows users to write transformers to implement specific features and customizations. And Akash had mentioned how customizations can help change the nature of output to suit a particular organization or individual project needs. So we will, in this particular segment of the talk, we will see how certain customizations can be affected and to produce output which deviates from the default behavior of Move2Kube. So that offers a very powerful mechanism for users to incorporate their own niche features without actually getting to know more about Move2Kube at all. So, and let's see how easy it is to achieve the goals. So to begin with, let's see, we use the same app that Akash had just demoed. That is the app which contains certain Java projects and Java services and JavaScript service and so on. This is the enterprise app. And this is the default output that Move2Kube has already produced without any customization. If you notice, it has three subfolders as previously mentioned. There's a deploy folder which contains deployment artifacts like the Kubernetes deployment YAML, ingress, services, and so on. And you also have scripts to build and push images. And you have the source folder which contains the source code of the individual services and a Dockerfile which helps users to build the image for the respective respective service. So let's say that I want to change this default output to something else. So to begin with, let's say I want to as already noted, Move2Kube already has inbuilt transformers. So let's say that I want to change the Docker image of this front-end app which is a Node.js app, which uses a Node.js base image. Let's say that I want to change it to a different image. And let's say that I want to add a startup script here instead of a simple command. And let's say that I want to pull out these YAML subdirectories out of the deploy folder, but inside the default output base folder. So let's say that I want to make these changes, so because it helps me to customize to my organization. So this is the first use case. Now we will use one of our customization plugins mentioned here, and let's see how easy it is to customize Move2Kube's behavior to achieve the goal that we want. So this is a very simple command, the same Move2Kube command that previously was used. And the only difference here is I add a -c option with the corresponding customization module. And let's see what it gives us. Okay, so now Move2Kube has generated the customized output. Let's compare it with the original output from the default behavior. So as you can see right away, the YAML folders that were there within the deploy subfolder are pulled out, and they have a different name here. And secondly, if you notice in the source folder, the front end service has a script called start.node.js.sh, which is the startup script, and it is being used in a Dockerfile. Previously, this image was a different image, which came by default, but we have a different image that suits our requirement, and we have a startup script instead of a simple command. So now that we have seen the customization, let's see how we can achieve this using the module. Let's see what the module does. So the module has two customizers, a Kubernetes customizer, which customizes the original default behavior of Move2Kube, overrides it using this override flag, and it also specifies the modified output path, so that all the YAMLs, deployment Kubernetes Yamls, are generated in this subfolders with this prefix. Secondly, if you notice, this is for the Kubernetes transformer, the override for the Kubernetes transformer. Secondly, let's see how the Node.js transformer, which processes the front-end app, is customized. So first thing you will notice here is, like in the previous case, this particular customization module overrides the default customization module that comes, which is built into Move2Kube. Secondly, you will see that there are two templated files. One is the Dockerfile, which contains the modified image, which overrides the default built-in image that Move2Kube provides. Secondly, you will notice that there's the startup script in the templates folder. So this is the one that gets injected into the Dockerfile and into the output. So this is how we can achieve this threefold customization with just simple YAML files and templates. So now that we have seen how we can customize the behavior of inbuilt by overriding the behavior of inbuilt transformers of Move2Kube. Now let's see how we can inject annotations or labels into a YAML that is generated by Move2Kube. So what I mean by that is, let's look at the default output. Let's take the ingress YAML here. If you notice the ingress YAML, you will see that in the metadata folder, in my metadata segment, there is no annotations of any sort. And let's say that this is the ingress, and I want to modify the behavior of the ingress to use the HA proxy instead of the default proxy, ingress proxy that is available in Kubernetes. So now let's run Move2Kube again with a different customizer module. It's the same command, but a different customizer in the -c option. Let's see its magic work. Okay. Now my project folder contains the customized output, and let's look at the ingress here. As we can see, there's an annotation injected into the ingress YAML, which was not previously there in the default output. So how could Move2Kube do this? How could we customize Move2Kube to do this? How was this achieved? Let's see that by inspecting the customization module. So this is the second customization module that we used. It has two files, a YAML, which describes the customization module. It's a very simple YAML, which says that it's consuming Kubernetes Yamls and it is producing Kubernetes Yamls. And this module overrides, hooks on to any Kubernetes YAML that is generated by any transformer within the inbuilt Kubernetes pipeline, and modifies that by looking at the YAML, sees whether it's an ingress YAML, and if so, it will add the annotation. So that part is done by the star file, which is referred to in the YAML here. So if you look at the star file here, you can see that there's a section from line 41 to 44 where the annotations are added to the ingress YAML once it is detected. So this detection happens here and the annotation is injected here. So this is a simple function, a single function, which takes in the artifacts, checks whether it's an ingress artifact, and if so, it adds the annotation and dumps the output artifact to the target folder. So these two files, when supplied to Move2Kube, Move2Kube understands the definition of these files and then runs them against the intermediate output that is generated to produce the necessary customization. So now we have seen how we could modify the behavior of inbuilt transformers. We have also seen how we can customize the output of the transformers, output of the transformers that Move2Kube has. Next, we will see how we can add custom files which are non-existent before, and in custom directory structures in the output. So again, we'll go back to our default output. We see that we have this default folder structure. There's a deploy folder, scripts folder, and source folder, within which all the custom services, individual services are located. Now let's say that we want to reorganize this folder such that every service has one a folder of its own, and its corresponding Helm chart is stored within that subfolder. So let's see how that can be achieved. Again, we will use the same command, pass a third customizer. Sorry. Clear the output. Okay. And the customized output is produced. As you can see here, the customized output has subfolders per service, and each service has its own Helm chart. And you can also see that each Helm chart is named after the service. Even the deployment, ingress, and service YAMLs are named after the corresponding service. So, and every service has its own Helm charts. Named after it. But on the other hand, if you see the default output, there is a consolidated Helm chart here instead of per service Helm chart. So this is the difference that you can effect by customization. So let's see how Move2Kube can achieve this type of customization. If you notice here, this is the third customizer that we used. It contains again a star file, a YAML file to define the customizer, and some templates. In this particular case, we have templated the Helm chart itself, and you can see the service name is parameterized here, templatized and parameterized here to be supplied by our customizer by understanding the source code and the configuration files of the input projects. And you can also see that we have a star file, and let's take a look at the star file here. If you notice here, the star file has two functions, a detect function and a transform function. The detect function detects the corresponding project, looks for sorry, a configuration file, the pom.xml, extracts the service name, and uses the service name to generate the output using the templates that have been supplied here. So this is how this particular star file generates the per service Helm charts. And if you can see here in the definition, this star file has been referred to as the definition of that particular customizer, and it consumes service artifacts, and it overrides any inbuilt artifact which does the same job, so that it can take over from it and produce the necessary target Helm charts in a customized manner. So that sort of completes the illustrative demos for customizing the output. Now we will see the power of another important and a very useful feature of Move2Kube, which is parameterizing and customizing the parameterization itself. And Hari will cover this part. Over to you, Hari.
Can you hear me?
Yeah, we can hear you, Harry.
So I'll just share the screen.
All right. All right, you're good to go.
Can you see the screen?
Yeah, you can see this. We can see your screen now.
Okay. So hi, everyone. So I'll be covering the parameterization part. So when you generate some Kubernetes YAMLs, everything usually gets hard coded, and you may want to have some sort of control over the different values that go into it. So here we have a sample application. It's all Kubernetes YAMLs. This is a web application which has a front end, which is in PHP. It has a backend in API that the front end calls. It's in Node.js, and the backend also has another service, caching service, which is Redis, implemented using Redis key store. So we'll see by default. So let's say you have these YAML files, these Kubernetes YAML files already. The values in here are hard coded, right? So the replicas are hard coded, number of replicas, the image name is hard coded, and lots of fields are hard coded. But we may want to have some sort of parameterization where you have a separate file where you specify all those values and fill these templates. So there are several ways to do it, and by default, Move2Kube comes with a good parameterization engine. So we'll just see that Ashok, Agas, and Naba have already shown that, but I'll just show it again just to. So I'll just copy the backup. This is simply just the application that we just saw. So I'll just run a transformation, Move2Kube transformation on that source. And we'll just look at the output. So this is by default, Move2Kube will copy over the source, and here it has parameterized. Move2Kube has generated a Helm chart with all the templates, and it has parameterized by default, it parameterizes the replica field. And it has also generated customized YAMLs, base and overlays, and also OpenShift templates. So these are some ways you can parameterize, 3 different platforms that provide parameterization. And Move2Kube is able to generate them just by the normal transform command. This is just for skipping the question answers. This is source folder, path to the source folder. So this is well and good, but we may want more control over which fields get parameterized. For example, we may want to parameterize the image field, And we may also want to change the default values that get put in here. So we'll see how we can do that. So this, I just deleted the output, and so I've created some parameterization transformers. As I mentioned, that everything in Move2Kube is a transformer, even parameterization. So we have a transformer which uses the parameterizer class. It consumes Kubernetes Yamls, and it produces all this Helm chart, OpenShift templates, customized, and so on. And the actual parameterization is given in a separate YAML file. The syntax is actually very simple. All you have to do is specify the path to the field that you want parameterized. So if we want to parameterize the replicas field, we'll say spec replicas, right? Because inside the deployment, it's under spec replicas. So and this syntax is just a dot notation which is used by other tools like YQ and so on. If you have used it, it's a common way to specify a path inside a YAML file. And this filters is used to select which YAML files you want to parameterize. So in this case, we only want to parameterize deployments, any version. So app v1, so on. And this template common.replica. So that is the final key that gets created inside the values.yaml if it's a Helm chart. So we'll just see that. So I'll just run the command. So the command is simple, just transform, give the path to the source folder, and also give the path to the customizations that you want to apply. So I'll just run that. So it has run, and it has produced this output. So here we can see it has generated the Helm chart with the replicas field parameterized, and inside the values.yaml we can see the common.replicas. So that's the simplest version, but we can do much more powerful things. So I'll just clean up. So we'll see a slightly more complicated example where we want to parameterize the image name. So as usual, we give the path to the field that we want parameterized. So in this case, inside a deployment, we want to parameterize spec, template, spec, container. So if you look spec, template, spec, containers, the first container, the image name. So so that's the field that we want to parameterize, and how we want to parameterize them is slightly more complicated. We may want to parameterize each part of the image URL separately. So the image registry URL, the namespace inside the registry, the image name itself, and also the image tag. So the all four of them can be they are all part of the exact same field, but we want to pull those values from different fields inside the values.yaml. So I'll just run this, and we can see what it generates. Look at the output now. Inside the Helm chart templates, we can see the image name is also now parameterized, and it's pulling from 4 different fields inside the values.yaml. So here we have the image registry URL, namespace, and containers, the first container, image name, and tag. So all 4 of these get combined into the final image name. So this is a slightly more complicated example where a single field needs to be combined from multiple fields in the values.yaml. But you may have noticed some issue here is that this would work fine if we only had a single deployment, but since we have multiple deployments, having all of those image names come from the exact same image name field in the values.yaml is not ideal. So we can. So that leads to our next example. So the next example is slightly more complicated, where, so as I mentioned, each deployment needs its own field in the values.yaml. So what you've done is the key itself that goes into the values.yaml is now dynamic. It depends on the deployment name and also on the container name, which we can extract from the original YAML file. So, and if I run that, then we can see that if you look at the values.yaml now, we can see that the image names are separate. It's the services and then the deployment name, the containers, the container name, and then the image name. So that gives us much more useful parameterization, where we still have a common image registry URL and namespace, but we have separate fields for the image names and the tags. Another thing to notice is that you may have noticed there's 3 different YAML files. So by default, Move2Kube generates 3 YAMLs for 3 different environments: dev, staging, and production. It's the same for customize as well, and also for OpenShift templates. This allows you to have different values for different environments. So in the dev environment, you might hard code the username, password, but in prod, you would have something else. And that is specified using this. Here we can say that the image tag, which we extracted. So the image tag should have different values in different environments. In dev, it should have beta 4. In staging, it should have RC2. In production, it should have stable version. And also for Redis, it has a completely different, because it's an external library container. So we can see that in prod, we have stable. In staging, we have RC2. So that's about a complicated way to parameterize certain fields. But we can go even further. Is Move2Kube also has a feature called a version conversion, where it can convert API resources to different API resources. So in this case, we have been dealing with deployment apps v1, but it can convert between different versions of the same API resource, but and it can also convert between different kinds of resources, as long as they are very similar. So we'll see an example of that. Let's say we want to target an OpenShift cluster. So so in the case of OpenShift cluster, I'll just run with without disabling the question answers. So Move2Kube will ask us some questions. So this is all the transformers that we want to run. This is the service that it detected. So here we are asked what cluster we are targeting. As we can see, there's lots of options. Default is Kubernetes, but you can also target OpenShift, IBM OpenShift, AWS EKS, and Microsoft AKS, Google, IBM AKS, all of that. So let's say we want to generate artifacts for OpenShift cluster. So we'll select that. And if you look at the output now, it has generated deployment configs. So because OpenShift has deployment configs, it has generated deployment configs, and with the proper API version and everything. And it's still parameterized as well. So you still get that as well. So it's a very powerful feature where you can target the API resources that are installed inside your cluster, and also parameterize the values for different, any arbitrary field inside this YAML file. And so in the parameterizer, all you have to change is we also want to parameterize for deployment config. So in the filters for YAMLs that you're targeting, you'll specify that. And so that's we saw how we can transform different, even if you already have Kubernetes YAML files, and if you're already running on Kubernetes, Move2Kube can still help you generate the Helm charts, OpenShift templates, customize YAMLs to make it easier to maintain your application going forward. So with that, I think I can throw it back to Ashok.
Thanks, Harry. Everybody, if you have any questions, feel free to put it in the comments. I know we don't have any right now, and I'm just going to bring the rest of the team on. Well, while we wait and give you guys a few seconds to put questions, I did put the Slack channel URL in the comments. That way, as you try to use Move2Kube, if you have any questions, you can just ping the team there, and I'm sure they're willing to help you out.
Yeah, and we have put in a lot of effort to make it completely customizable. So do give it a spin. And if you have new requirements, do feel free to comment the issues or chat up in the Slack channel, and we would be happy to help you with your use case.
All right. Well, I don't see any questions, guys. So everyone, if they do come out, if you do come up with new questions, like again, just put it in the Slack, and the team will be there, so they'll be able to answer it. Ashok and team, thank you guys for doing this. I know it's late on your time, but well, we appreciate all the insights you gave us today. Well, with that, everyone, we'll call it a day, and we'll see you next time. Bye.
Thanks.
Thank you.
Thank you.